Alright, so we're really going to try to test to see if there's a relationship between our two categorical variables. So we're going to talk through what that test is going to look like and sort of what our data would look like under the situation where they're not related. So our question that we're really asking is, does the response variable appear to differ by explanatory variable? Okay, what that means in our example is, are these numbers different basically for those that didn't vote for Trump and those that did vote for Trump? So basically, are these values considerably different from each other? If our answer is yes, we say the response variable is dependent on the explanatory variable. Or in a sense, what we're really saying here is that there is a relationship between the two variables. So the one is affecting the other. First, we said the answer is no, so no, the response variable is not different based upon the explanatory variable. Then the response variable is independent of the explanatory variable. Or in a sense, there is no relationship between our two variables. So let's just talk a moment for understanding with our data, what would it mean if they were independent? Or basically, your feelings about the president is not related, has no effect based upon if you had voted for him or not. So what our percentages would have looked like would have been the following. We would have got 56% here, 6% here, and 38% here, so for a total of 100%. We also would have got 56% here, 6% here, and 38% here, for a total of 100%. So the first thing that you'll notice is that if there was no relationship, the percentages would be the same for both rows. That is telling me exactly what this is saying. So the response variable, so disapproving being neutral or approving, is not affected at all by if you voted for Trump or not. It's having no effect. You're just as likely to approve of the president if you didn't vote for him as if you did vote for him. Now, specifically, where did these numbers come from? These numbers came from the overall percentage that we had before. So it's just ignoring if they voted for Trump or not, which is exactly what our first graph looked at. So that's where those numbers are coming from. That was our original percentages here. So then a graphical idea of what independence looks like is that your pie charts will look exactly the same, whether you didn't vote for Trump or whether you did. The same percent approved, the same percent disapproved, and the same percent were neutral. So there'd be no visual difference in your pie charts if they're independent. So going back and then looking at our pie charts, do they appear to be very visually different? That's sort of what we're going to be testing here, is how different are our pie charts. So we've seen what independence looks like visually as well as percent-wise. What we're also going to look at is what our independence looks like from a count perspective. So to understand this, we're going to actually be using these two different numbers when we test for independence. The first one is the observed count, or our actual data. So those were these numbers that we got here. This is our actual data that we had. These are my observed counts. Then we're going to have what's called an expected count. An expected count is the number we would expect if the variables are independent. And so if they're independent, this is what our counts should look like. Now, how do we actually calculate the expected count? There's two different formulas we have here. So the first one just uses totals. The second one uses a row percent in a decimal form. And this is based upon when they're independent as well, times our row total. So the easiest way to understand this is done by actually doing our example. So the first thing that I need are my row totals, because those are going to be exactly the same. I also need my column totals, because those are going to be exactly the same. So when I'm looking at expected counts, I don't get to change any of my totals. Those are all the same, and these are the numbers I'm going to use to calculate them. So let's first look at those that didn't vote for Trump and disapproved. So using this first formula, we're going to take the row total, which is 1,361, times our column total, which is the 1,400. And we're going to divide that by our overall total, which is 2,500. See what this looks like in our other formula. The first thing I need the row percent in decimal form based upon independence. What that's going to be here for us is this 56%. So this is going to be the same thing as 56% of my row total, which is 1,361. And so what we get here is 762.16. Moving over now to those that did not vote for Trump and were neutral. So I'm starting with my row total, same row total, because I'm in the same row. My column total is now in the neutral, so we used 150. Out of our total sample size of 2,500. Using the other formula here for it, we need the row percent decimal form, so that's going to be our 6%, so that's 0.06, times our row total of 1,361, giving us 81.66. Now at this point, you actually don't have to do any more calculations if you don't want to, because all of my totals are fixed. So I can find this number by knowing this plus this has to be 1,400. I can find this number by knowing that this plus this has to equal to 150. I can then find this number because this plus this has to be 1,361. And then I can find many different ways to find my last number here. But you can always use the calculation if you want. And so I must have all those calculations done. I just got those that voted for Trump and approved left. So my row total is 1,139. My column total is 950. My overall total is 2,500. Which then is the same thing as 1,139 times our 0.38. Should get us the 432.82. So this is what our row totals would look like if the two variables were independent. That is, if there was no relationship between the two variables, these would be the totals I would expect to get. So what we're going to really want to do is, here's what we would expect to get. And then we have what we actually got. And we're going to compare those two numbers. So how different is what we got compared to what we expected to see. But we're going to formally do this through the hypothesis test, looking at it in the same steps that we already have. So the first step is always our null and alternative hypothesis. So the null hypothesis is going to be that the response variable is independent of the explanatory variable. Or in a sense, again, our null hypothesis would be that there's no relationship between our two variables. So the one is not impacting the other. Our alternative hypothesis will then be that the response variable is dependent on the explanatory variable. That is, there is a relationship between our two variables. Our second step is the same as it was before of our decision rule. We will still reject the null hypothesis and believe the alternative hypothesis when our p-value is less than that alpha, that significance level, and this will generally be a number that's given to us in the problem. Our step 3 has conditions in it when we're asked to check them. So the first thing I need to do is check to see if I have a random sample of the population or a random sample of my subgroups, or sort of the stratified sampling here. And then all of my expected counts have to be at least 5. So we will be checking those expected counts. The other part of step 3 is always our test statistic. Now, up until this point, we've always been calculating a z. And a z we're very comfortable with. Unfortunately, a z does not work here. We have what's called a chi-squared test statistic. And although knowing that this is chi-square is not real important, it's going to make our lives a little bit easier when we go to StatCrunch and also look at our output that we have. How we calculate a chi-squared. So the first thing we're going to use is this cap sigma, which really just means to sum, or that we're going to add some things up. And how we do that is we take our observed count minus our expected count, square it, and we divide by our expected. So if we're looking at our example, I'm going to have 1, 2, 3, 4, 5, 6 expected counts. And for each of those, I have a corresponding observed count as well. So I'm going to use this for my observed count for the first one. This is my expected count for my first one. I'm going to calculate this number, and then I'm going to do the same thing for all other 5 options and add them up, and we will do this in the next video as an example. But let's first have an idea of what I'm looking for. So, if the observed is equal to the expected, so basically I get exactly what I expect, this chi-squared is going to turn out to be 0. So I'm going to get observed minus expected will just be 0. I square 0, I still get 0. Doesn't matter what I divide by, I still get 0. So if I get a chi-squared equal to 0, that is basically they're perfectly independent. There is definitely 0 relationship between them. The larger the chi-squared, the more evidence of a relationship. So the larger this chi-squared, the more evidence there is of a relationship, because that means my observed and expected are more different from each other. Which, remember, the expected is assuming there's no relationship. So if my observed and expected are very different, that gives me evidence that there is a relationship. And we'll talk about that in a little bit more detail when we do an example as well. For our step 4, we're going to calculate our p-value, which is going to be going to StatCrunch. Step 5 is going to be our conclusion and interpretation. So we're going to be using StatCrunch for this one. And so there's going to be 2 different ways that we're going to do it. And I'm actually going to go ahead and show you how to get the output we're going to use for our next video when we do the example. There's 2 different ways we can have the data we want. We can have just a summary, or we can have the actual data. And so first, once we're in StatCrunch, what it means to just have the summary would mean that we just have the contingency table itself. So I'm just going to enter in our contingency table. And when we do this, we don't include the totals. The StatCrunch can do all of that math for us here. These are the exact numbers that we have here on page 4 in the notes. And again, I'm just not going to put in the totals, I'm just going to put in the other numbers. And then as our directions say, I'm going to go to Stat, Tables, Contingency with Summary. So Stat, Tables, Contingency with Summary. Then I got to ask it which columns do I want to compare, basically which of my columns have numbers in them. And as it says there, if I want to click more than one thing, I just got to hold the control while I click them. So I'm going to hit my disapprove and control my neutral, control my approve. So I need to tell what my row labels are. So kind of where did I label my rows is in this voted column. And there's some extra things that we can get here. We can get the row percentages that we actually have already calculated, and I get the expected counts that we also have already calculated. And then I'll hit compute. So here's the output I get. So what you'll see in this output, and this output is on the last page of the notes that you have, is that we get the first thing we have is a cell format. And what that allows me to do is when I look down here, tell me what each of my free numbers are. So the first one is the count, or the observed count, the actual data, same numbers I put in here. The second thing there in parentheses is the row percentages. And the third thing is the expected counts. So you'll see these match what we've already done before. So here were our row percentages, so that's that second set given to us here in the output. And then the third one is our expected counts, the same numbers that we calculated in the last video. So the exact same numbers are provided here for us. The bottom part is where more of our hypothesis test stuff is actually going to be. So it's called a chi-squared. This value is the actual value of the chi-squared. That is when you actually do this whole calculation. This is the number that you would get. And then we're given our corresponding p-value. This was one way to get to the output. The other option is when you actually have the data. So the first thing I'm going to do is locate my data and upload it here. So I found my president data set. It'll show me a little bit about what it looks like when I bring it in. Let's hit my load file. So in comes the data. Now we're going to be following that second set of options. So we're going to go to Stat, Tables, Contingency with Data. So Stat, Tables, Contingency with Data. And then here it looks a little bit different since your data is organized different. I can say what's my row variable, which is my explanatory variable. So that was whether or not they voted for Trump. My column variable, or my response variable, was their opinion about the president. And then the same thing, I can click down here, my row percentages, and my expected counts. We hit compute and get the same output that we had before. Only that's a little bit different here, is since it used my data, it automatically puts things here in alphabetical order compared to how I had them listed as the disapprove, neutral, and then approve. But it's the same numbers, just the columns have been reorganized. So that's the two different ways to get the output from StatCrunch. In the next video, we're going to actually do a full example of going through the hypothesis test and show us how we can calculate that chi-squared test statistic.